welcome, ladies and gentlemen. So what I'd like to do is show you how to determine the truth of a given conditional statement. And we're not going to just look at a conditional statement. We're also going to look at the converse, the inverse, and the contrapositive, as well as talk about which of those are what we call logically equivalent. So the first thing is we're going to look at our statement, which we have a conditional statement here is, and this first one says, if you have a square, then you have 4 sides. So what we want to do is determine if that statement is true or not. And if it's not true, therefore it's false, we're going to want to give it a counterexample. Okay? So we want to say, hey, it's not true or it's false because here's a counterexample. Here's a reason that shows it's not true. So if you have a square, then we have 4 sides. Well, we know that the definition of a square is 4 equal sides, 4 right angles. So that looks like that's part of the definition of a square. So of course, I can say that that is going to be true. Okay? Now let's go and take a look at the inverse of that statement, which is basically going to be the opposite of our hypothesis and our opposite of our conclusion. Remember, this isn't in conditional form. You can see that underlined here, the if and the then. So what happens after the if is what we call the hypothesis, and then after the then is what we have the conclusion. So the inverse is going to be the opposite of the hypothesis. So we'll say inverse. That's going to be the opposite of my hypothesis. So the opposite of having a square would be not having a square. And remember, the inverse is just basically the opposite of whatever it is, right? So if the opposite of if you have a square, so if you do not have a square, then the opposite of having 4 equal sides is not having 4 equal sides. Then you do not have 4 equal sides. And let's go and see if this is true. So you don't have a square. That means you cannot have 4 equal sides. Well, that is actually going to be false, because if we look at this, we know that a rhombus is a figure that has 4 equal sides but does not have 4 right angles. So therefore, that statement is going to be false. Let's go and take a look at the converse. The converse is not going to be dealing with any negation. All it is swapping our conclusion and our hypothesis. So instead of saying if you have a square, then you have 4 equal sides, the converse is going to say if you have 4 equal sides, then you have a square. So if you have 4 equal sides, then you have a square. And again, this is going to be false because, again, if you look at this rhombus, here's my counterexample. If you look at this rhombus, this has 4 equal sides, but it does not have a square. So the first part is true, but the conclusion is false. Therefore, the statement is false. If you have a square, then you do not. So then the last one is to look at the contrapositive. Contrapositive. And the contrapositive is going to be the opposite of the conclusion, then the opposite of the hypothesis. So if you do not have 4 equal sides, then you do not have a square. So if you do not have 4 equal sides, then you do not have a square. And you can see that that goes exactly against what our definition of a square is. A square has 4 equal sides and 4 right angles. So if you don't have 4 equal sides, you obviously cannot have a square. So therefore, the contrapositive is going to be true. Now, the last thing I mentioned on my introduction is we want to talk about logically equivalent. You can see that the conditional statement and the contrapositive are true. Those are what we call logical equivalent. So when 2 statements have the same truth validity, you can say they're logically equivalent. Whereas the inverse and the converse are both false, so therefore those are going to be logically equivalent. So let's go and take a look at the next one. The next one says if you have a polygon, then it is a regular polygon. Well, we know off the bat that is going to be false, because remember, regular polygons have equal side lengths as well as equal angle measurements. So I'm going to say that's false. And I'll just draw a picture here, of here is a pentagon that obviously is not regular. The sides are not the same, nor are the angles. but it does have 5 sides. So it is a polygon. It is, it is a closed two-dimensional figure. It's closed, but it is not regular. So that is false. Let's go ahead and find the inverse. So the inverse, I'm just going to negate the hypothesis is you have a polygon, and then I'm going to negate the conclusion is it is a regular polygon. So inverse is you do not have a polygon. So inverse, you do not have a polygon. Then, or if you do not have a polygon, then you do not have a regular polygon. So let's go and see, what exactly would be an example of, well, let's say you do not have a polygon, then you do not have a regular polygon. Well, that is true because only regular polygons have to be, polygons. I mean, a famous regular polygon would be a square. Well, if you have if you have a regular polygon, that means it has to be a polygon. The regular portion is what just tells you has equal side lengths and equal measurements. So if you don't have a polygon, it's impossible for you to have a regular polygon, right? So therefore, that statement is true. If we go and take a look at the converse is just going to be swapping the conclusion and the hypothesis. So therefore, it's if it is a regular polygon, then it is a if it is a regular polygon, then you have a polygon. So, if you have a regular polygon, then you have a polygon. And that's kind of very similar to like the inverse, our justification for the inverse being true. Obviously, if you have a regular polygon, that means it is a polygon, right? You can't have a regular polygon and it not being a polygon. Regular just means it has equal sides and equal measurements. So therefore, that is true. And then last but not least is let's do the contrapositive. So the contrapositive is going to be conclusion, opposite of conclusion, opposite of hypotenuse. So if you do not have a regular polygon, then you do not have a polygon. So if you do not have a regular polygon, then you do not have a polygon. Well, we know that is going to be false. Again, we could use my same counterexample, or we could just use another one. So it's saying you do not have a regular polygon. Well, a rectangle does not have to be regular, because a rectangle, could have all same sides, but you could have, opposite sides are not all the same. So you don't have all the same. So it's not regular. However, that's not a regular polygon. But that is still a polygon. So therefore, this contrapositive is false. And again, look at my logically equivalent statements. You can see that the conditional and the contrapositive are logically equivalent, and the inverse and the converse are logically equivalent. So it doesn't matter if they're true or false, if they're logically equivalent or not. The conditional statement and its contrapositive are always logically equivalent, as well as the converse and the inverse. So there you go, ladies and gentlemen. That is how you determine the truth of your conditional statements, as well as determine logically equivalent statements. Thanks.